By now, you've probably seen Elon Musk's announcement. SpaceX has already shifted its focus toward building a self-growing city on the moon. And the reasoning behind that shift is straightforward. You can build a moon base in 10 years. It will be hard, but it's not impossible. Building a city on Mars would take at least 20 years, if it's even achievable. Realistically, there's always been a chance it simply doesn't work. If someone gets sick on the moon, they can come home. The journey to Mars was always going to be a one-way trip. So we understand why this shift is happening, but what's about to unfold will look more like science fiction than anything NASA has ever imagined. What exactly is a self-growing city on the moon? It's a phrase that's deliberately provocative yet intentionally vague. But self-growing city gives us a strong hint about the direction: AI, automation, and robots. It's no coincidence that SpaceX recently acquired xAI. This company is best known for its versatile AI language model, Grok. And through xAI, we've learned the most specific details yet about what Elon actually plans to build on the moon. The first element will be satellites. SpaceX intends to build satellite factories on the lunar surface, sending them directly into orbit. These won't be like Starlink. They'll be orbital data centers designed to run advanced AI models for use back on Earth. And to manufacture those satellites, they'll be using raw materials harvested directly from the moon itself. This leaves one big question. Why does SpaceX need to go to the moon to build AI satellites? Because SpaceX is trying to solve the hardest part of the equation, moving a satellite from the ground into space. To get those satellites into orbit, SpaceX will construct a mass driver, sometimes referred to as a railgun. It operates like a train on a track, accelerating an object to escape velocity and flinging it into space using electromagnets. It's similar to the technology that allows an electric car to launch from 0 to 60 in 2 seconds. And as it happens, Musk has considerable experience in that field already. This is his ultimate engineering challenge. Because the moon has no atmosphere to create wind resistance, it has a much lower escape velocity. On Earth, that figure is 11.2 kilometers per second. On the moon, it's just 238. That's a massive difference. Reaching space from the moon would be vastly simpler than the enormous complexity of launching from Earth. From the lunar surface, you don't need rockets, fuel, or hardware that demands constant maintenance. It all comes down to magnets, a steel rail, and electricity. The lunar industrial revolution has begun. Now, who is going to build all of this on the moon? It won't be people in spacesuits. It will have to be robots, specifically the Tesla bot, Optimus. Building on the moon presents a fundamental challenge. We can't bring Earth's resources along with us. Even the mighty Saturn V could barely deliver enough for 2 people for 3 days. Musk's goal for Optimus is self-replicating technology, inspired by the von Neumann probe, a machine that lands, harvests materials, and builds copies of itself. This is what people hope for when interstellar objects pass through our solar system, the chance to witness an ancient alien probe in action. For Optimus, this means robots mining ore, producing plastics, and fabricating microchips, all on their own, without human intervention. This is more than construction. It's a complete supply chain on the moon. Shipping everything from Earth on rockets simply isn't an option. Even with Starship providing the muscle, the first fully reusable super heavy lift vehicle, the math doesn't work if everything has to come from Earth. Starship can carry more cargo than any other rocket, refuel in orbit, and fly to the moon or Mars. It is the cornerstone of this entire operation. We've seen Starship milestones over 3 years. Some land, some explode. It's a work in progress. But the goal of a lunar landing next year remains. Beyond power, Starship offers a major advantage: the vehicle itself. Once landed and empty, it becomes a metal cylinder 60 meters long. A single hollowed-out Starship offers the same internal volume as the entire International Space Station. It's an instant human habitat. To stay safe, these ships will be buried under lunar soil. This layer of insulation protects against radiation, temperature extremes, and meteorites. We are witnessing the birth of a new era. From robots to recycled rockets, the moon is no longer just a destination, it's our next home. So we have somewhere to live. But we didn't go to the moon just to stay indoors. We need to get around, and SpaceX will have an answer for that as well, borrowed from their friends at Tesla. The Cybertruck. You wouldn't send a standard one to the moon. It's overbuilt and wouldn't survive the environment. But the underlying concept is sound. NASA used electric vehicles in the 70s, and they performed well. The range of those old Apollo buggies was just under 100 kilometers on a non-rechargeable battery. Impressive for the era. Imagine how far we could go today on a single charge. Tesla's autonomous AI would also play a major role, allowing vehicles to transport robots and raw materials across the surface without human involvement, freeing people for science and exploration. At the heart of this self-growing city, though, is energy. A lot of it. Powering a massive AI satellite factory and a mass driver requires an enormous solar infrastructure, and that energy will come from the sun. A significant strategic change Musk has made is a focus on solar manufacturing. He's directed his companies to build panels domestically, targeting 100 gigawatts of capacity per year. To put that in perspective, 100 gigawatts is roughly one-fifth of current US electricity generation. Over 5 years, they could power the entire country on their own. But the majority of that output is intended for space. Every AI data center satellite will require a large array of solar panels to power the supercomputers inside. A solar panel for space is fundamentally different. There is no weather in space or on the moon. You don't need heavy glass or metal casing. If a cell takes a hit from a meteorite, you simply swap in a new one. This illuminates what Tesla means by amazing abundance. When energy is cheap and labor and transportation are automated, you can build virtually anything. Progress is limited only by our capacity to invent. So yes, we can build a city on the moon, and then we can go to Mars and do the same thing. The journey has just begun. There's another vision waiting for us on the red planet. But for now, the moon is our training ground for the stars.